Since the Chinese rover's landing on the moon, mounting evidence suggests this celestial body differs significantly from our long-held conceptions, particularly in its subsurface. The moon appears to conceal a treasure trove of resources previously unknown. The rover's shocking discovery could fundamentally reshape our world. This article examines the rover's lunar findings and their potential to avert a looming climate catastrophe. The Chang'e 5 mission, launched December 1, 2020, from the Wenchang Space Launch Center in Hainan Province, after a 23-day journey, deployed a two-part probe. This same launch complex has hosted previous Chang'e missions, numerous satellites, and supply runs for the Chinese space station. Following successful separation of the orbiter, the Chang'e 5 lander touched down in the Oceanus Procellarum, a vast, flat region near the lunar equator on the near side, characterized by its extensive plains and proximity to Mons Rumker, a mountain approximately 5,250 feet high. The nearly 8-ton probe's primary objective was the collection of lunar surface samples, marking the first return of lunar regolith to Earth in 40 years. This mission aimed to retrieve samples from deep lunar strata. In recent years, scientists have come to understand the moon may be vastly different than previously believed, potentially holding substantial mineral reserves that could solve our energy crisis. After successful drilling, the lander transmitted samples back to its orbiter via an ascent module, beginning the return journey to Earth in just 14 days. This mission was globally hailed as a significant achievement for Chinese space exploration, solidifying China's position among the world's leading spacefaring nations. The return samples were eagerly awaited by international researchers, and initial analyses indicate expectations of revolutionary lunar knowledge have been surpassed. The return capsule entered Earth's atmosphere on December 17, 2020, and landed successfully in sparsely populated areas of Mongolia. Upon securing the samples, specialists began their analysis, eager to confirm or refute existing lunar formation theories. Scientists believe a Mars-sized planet collided with Earth over 4 billion years ago, forming the moon. During this impact, a portion of Earth broke off, covered in molten rock. It was previously assumed temperatures were so high that any water would have evaporated permanently, classifying the moon as a desiccated celestial body gradually shrinking or drying up. However, recent telescopic and probe observations have revealed substantial deposits of water ice within craters near the lunar poles. This sparked questions about the ice's origin and why it remained undetected for over 50 years of intense lunar study. NASA plans to send astronauts to the poles within the next 10 years as part of the Artemis program to determine the feasibility of using lunar water for planned permanent lunar bases. This water could sustain human life, enable plant cultivation, and provide fuel. However, the Chang'e 5 discovery could completely alter these plans. The rover found an unexpectedly large quantity of water throughout the moon, seeming impossible for such a small celestial body. Analysis of lunar samples by researchers from the Chinese Academy of Sciences revealed an unusually high density of microscopic glass particles. These tiny glass crystals likely formed from meteorite impacts on the moon, with cometary impacts also potentially delivering water that now exists as ice at the poles. Closer examination of these impact glass beads revealed another astonishing secret. While each particle contains only a minuscule amount of water, their collective abundance makes lunar water reserves immense. Each crystal contains approximately 2,000 parts per million of water, a seemingly small amount given that the beads themselves are less than a millimeter in size. However, scaling this concentration across the entire moon yields roughly 2,000 kilograms of water per metric ton of lunar soil, the equivalent of 2,000 liters of liquid water under Earth conditions. Given that the moon has been bombarded by comets, asteroids, and meteorites for billions of years, the widespread distribution of these glass particles suggests the moon might be water-rich from the equator to the poles. This eliminates the need for future crewed lunar missions to land at the poles and painstakingly utilize the water ice found there. The water within these beads can be easily extracted through heating, providing lunar settlers with fresh water anywhere on the celestial body. Further research by Chinese scientists demonstrated that the water trapped within these lunar crystals was once produced by the sun. According to the theory, positively charged hydrogen atoms from the solar wind penetrated the glass beads and combined with the oxygen contained within. The study of different types of hydrogen atoms in the sample showed that these glass beads can also release some of their hydrogen charge at high temperatures when heated by solar radiation. Current estimates place the total water abundance within these impact glass beads at approximately 298.7 billion short tons, far exceeding NASA's 2010 estimate of 661 million short tons of water at the Moon's North Pole. This enormous quantity is impressive even in comparison to Earth. Our planet, comprised of both water and rock, contains roughly 1.47 quintillion short tons of water. While the idea of a moon with rivers, lakes, and even oceans, due to chemical or mechanical alterations within the water glass beads, is fantastical, creating flowing water on the moon's surface is unlikely. The moon lacks a substantial atmosphere, experiences extreme temperatures, and possesses very low atmospheric pressure, preventing water from liquefying under its conditions. Furthermore, the moon's low density and weak magnetic field do not suggest future changes in this regard. This contrasts with Mars, where liquid water once flowed, as evidenced by erosion traces, and terraforming plans aim to transform Martian polar ice into liquid water through artificial greenhouse effects, though its feasibility remains debated. Returning to the fascinating discoveries by Chinese astronauts, the glass beads contain more than just water. This captivating finding could soon trigger a breakthrough in lunar exploration and potentially solve Earth's energy problems. The samples collected by the Chinese space probe are unique, originating from deep layers and being approximately 1 billion years older than surface samples collected by astronauts during the Apollo program. These glass beads likely formed predominantly over the last 2 billion years due to massive meteorite, asteroid, and comet impacts. The necessary temperatures require impacts comparable in size to the asteroid that wiped out the dinosaurs approximately 68 million years ago. As a relatively small celestial body, the Moon has endured massive cosmic impacts throughout its history, and its survival is attributed to its low density and thick, cushioning layer of dust. This tumultuous lunar history may have yielded various features offering substantial future benefits. Chang'e 5 also discovered another crystal in the lunar regolith, potentially significant because it is made of a previously unknown substance. Researchers were astonished to find a crucial component for nuclear fusion within this structure. For those unfamiliar with nuclear energy, it's worth noting that Earth's energy problem will be solved once nuclear fusion becomes feasible. Until now, nuclear fission has met our enormous energy demands, but the resulting radioactive waste has become a major problem. Nuclear fusion, however, involves fusing light atomic nuclei into heavier ones, releasing far more energy than fission with no radioactive residue. Physicists worldwide have been working on this technology for decades without success because the pressure, and thus the energy required to fuse nuclei, exceeds the energy gained. This problem would be instantly solved by finding minerals naturally predisposed to nuclear fusion, which is precisely what has happened. The extracted phosphate mineral has been named after the Chinese moon goddess mission. Future research at the Beijing Uranium Geological Research Institute will determine the terrestrial viability of its fusion-ready helium-3 isotope. This could lead to lunar mining operations, with spacecraft delivering the mineral to Earth daily, offering our planet respite. The Chang'e 6 mission, starting in 2024, aims to collect additional samples from the far side of the Moon. NASA is closely monitoring these developments. Experts estimate the U.S. could power itself for a year using approximately 27.6 short tons of helium-3, easily transported by a space shuttle. The economic value of lunar helium-3 is estimated at $3 billion per short ton, potentially sparking a gold rush and attracting numerous companies to the Moon. Some major energy corporations have already approached NASA about investing in future space missions, potentially significantly bolstering the Artemis program.